In 7.4, we're going to do some special types of trinomials. One of them is actually a binomial. And of how to factor those. And if you remember in the previous chapter when I said that you should learn some of these shortcuts, here's where that becomes useful. So the first thing we're going to do is a square trinomial. And that is one where you have something like a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. And to factor this, it would be a plus b squared for the first one, and a minus b in parentheses squared for the second one. So what you're looking at is whatever sign the middle term has, that's what sign the binomial has. And you could write this first one as a plus b times a plus b, and the second one a minus b, and you'll still be correct. It's just that this way here is a little bit less writing or typing. So what we're going to do is to determine if a trinomial is a perfect square, first we're going to look at a squared and b squared, and those are the first and last terms, and we're going to say, are they perfect squares? So for instance, if you have x squared for the a and 9 for b, or b squared for the last term, or let's say you had 4x squared for the first term and 64 for the last term. Those are all perfect squares. So then, is the middle term either 2 times a times b or negative 2 times a times b? So what we're going to look at is the first term and the last term. And are they perfect squares? If so, then what we're going to do is take the square root of those and see if the middle term is 2 times the square root of the first one times the square root of the last one. So before we do any of that, let's look at just some individual numbers to see if they are perfect squares. So 1, that's a perfect square. Square root is 1. 4 is a perfect square. Square root is 2. X squared is a perfect square. The square root is x. X to the 4 is a perfect square. The square root is x squared. X to the 6 is a perfect square. Square root is x to the 3. X squared, y squared is a perfect square. The square root is xy. 81, x squared is a perfect square. Square root is 9x. And 9x to the 4 is a perfect square. The square root is 9x or 3x squared. So what about 1/4? 1/4 is, the square root is 1/2. X to the 10 over 9. The square root of this is x to the 5 over 3. For the variables like this, you just take half of what the exponent is, and that's what the square root is. We'll be doing more of that in a future chapter as well. So now let's look at some polynomials. X squared plus 4x plus 4. Okay, so we're going to look at the first term and the last term. Are they perfect squares? Yes. The square root of x squared is x. The square root of 4 is 2. So now 2 times x times 2 equals 4x. That means this whole thing, and that's what this middle term is the same as this. So that means this is a perfect square trinomial. The first questions, that's all it's going to be asking you. But if we wanted to do the square or the factorization of this, it would just be x plus 2, the whole thing squared. The reason we got the x is the square root of the x squared. The 2 is the square root of 4. The way we got the plus is because this middle term is plus, and we just squared the whole binomial. Next, let's say we have x squared plus 12x plus 36. So the square root of the first term is x. Square root of the last term is 6. 2 times 6 is 12 times x is 12x. So this is a perfect square trinomial. So we can just say x plus 6, the whole thing squared. Or we can say x plus 6 times x plus 6. Then let's say we have x squared plus 20x plus 100. Square root of x squared is x. Square root of 100 is 10. 2 times x times 10 is 20x. So it's going to be x plus 10, the whole thing squared. Remember, on these, this last term has to be positive. The middle term can be positive or negative. So for instance, if we have x to the 4 minus 4x squared plus 16. Okay, so the square root of x to the 4 is x squared. Square root of 16 is 4. I'm sorry. This should be an 8. Hold on a second here. Okay, so we have x to the 4 minus 8x squared plus 16. Okay, the square root of x to the 4 is x squared. Square root of 16 is 4. 2 times 4 is 8. Times x squared is 8x squared. So our answer here will be x squared. This is a minus. And 4, the whole thing squared. In the next part of this section, you're going to see what more we should actually do with this one. Then let's say that we have 4x squared minus 20x plus 25. So the square root of 4x squared is 2x. Square root of 25 is 5. 2 times 2x times 5. 2 times 2x is 4x times 5 is 20x. That is what the middle term is here. So our answer here is going to be 2x. This is a minus, so minus 5, the whole thing squared. Then let's say that we have x squared minus 2xy plus y squared. Square root of x squared is x. Square root of y squared is y. 2 times x times y does equal 2xy. So our answer here would be x minus y, the whole thing squared. It's a minus because this here is a minus. Okay, so a few more. Actually, let's look at this one. 25x squared plus 25x plus 25. Okay, so square root of 25 is 5. Square root of 25x squared is 5x. But 2 times 5x is 10x times 5 is 50x, which is not what this middle term is. So even though the first term is a perfect square and the last term is a perfect square, this is not a perfect square trinomial. Okay, so let's look at a few more here. 9x squared plus 24xy plus 16y squared. Okay, so take the square root of the first term, and we get 3x. Square root of the last term, and we get 4y. 2 times 3 is 6, times 4 is 24, which is what we have here. So our answer is going to be 3x, and it's a plus 4y, the whole thing squared. Let's say we have 9x to the 4 minus 6x squared plus 1. Square root of 9x to the 4 is 3x squared. Square root of 1 is 1. 2 times 3x squared times 1 equals 6x squared, which is what we have here. So our answer is going to be 3x squared minus 1, the whole thing squared. And let's look at this. 9x squared plus 15x plus 4. Let's say we have to do this, take the square root of this, or factor this. Square root of 9x squared is 3x. Square root of 4 is 2. 2 times 2 is 4, times 3 is 12x. So that isn't what the middle one is. So if we had to factor this, we would have to do it like we did in the previous section. And so what I'm going to do is all the factors that exist for 9 are 1 times 9 and 3 times 3. The ones that exist for 4 are 1 times 4 and 2 times 2. We know that we're not going to pair 3x and 2, but like I said before, start with the ones that are closest to each other. So 3x and 3x, we see that we have two pluses, so these are going to be pluses, and we have to add up to 15. So I'm going to try the 1 and the 4. And so I have 3x plus 1 times 3x plus 4. If I do FOIL on this, I'm going to get 9x squared plus 12x plus 3x plus 4, which equals 9x squared plus 15x plus 4, which is what I started with. So this is the right answer. There are going to be times, like this shows, that you have a perfect square for the first term, a perfect square for the last term, but it's not a perfect square trinomial, but you are still able to factor it. Then let's say that we have 8x squared plus 40x plus 50. Okay, here, 8 isn't a perfect square, neither is 50, but if you notice, all these are even numbers, so we can factor out a 2. When we do that, we're left with 4x squared plus 20x plus 25. And now we have a perfect square here and a perfect square here. Square root of 4x squared is 2x. Square root of 25 is 5. 2 times 2x is 4x. Times 5 is 20x. So that inside here is a perfect square trinomial. So we need to keep the 2. And we're going to have the 2x. This is going to be a plus. We're going to have the 5. And then square for the binomial. Okay? And let's say that we have 25x squared minus 20xy plus 4y squared. Square root of 25x squared is 5x. Square root of 4y squared is 4y. 2 times 5x is 10x times 2y, or this is 2y, times 2y is 20xy. So we're going to have 5x minus 2y, the whole thing squared. And the last one of these, 12x to the 3 minus 84x squared plus 147x. Okay, we can factor out an x here, and we can also factor out a 3. So when we do that, this is going to be 4x squared minus 28x plus 49. So now the square root of 4x squared is 2x. Square root of 49 is 7. 2 times 2x is 4x. Times 7 is 28x. So we need to keep our 3x. We're going to have a 2x. This is minus 7 squared. The next type of a problem that you're going to get is a difference of two squares. These are the easiest ones to factor. You're always going to have just two terms. There's going to be a minus sign in between, and they're both going to be perfect squares. The form that they're going to take is a squared minus b squared. If you remember, this is one of them that we got an answer to when we were doing FOIL. And if we want to factor this, it's going to be a plus b times a minus b. So all you're going to do is take the square root of both of them. You're going to have two binomials with those two numbers. One's going to be plus, one's going to be minus. So x squared minus 25. Square root of x squared is x. Square root of 25 is 5. So we're going to have x and 5 in both binomials. One's going to be plus, one's going to be minus. If we have x to the 4 minus 9. Square root of x to the 4 is x squared. Square root of 9 is 3. We have 1 plus, 1 minus. This time I'm going to put minus and plus because it doesn't matter what order you put them in. We can do this even with ones that are fractions. X squared over 4 minus 9 over y squared. Square root of x squared is x. Square root of 4 is 2. Square root of 9 is 3. Square root of y squared is y. 1 is plus, 1 is minus. So again, these are the easiest ones to do. They're gonna be the ones where you have two terms. There's gonna be a minus sign in between, and they're both gonna be perfect squares. Let's say that we have 4x squared minus 49. Square root of the first is 2x. Square root of the second is 7. We have 1 plus, 1 minus. Now, however, let's say that we have something with two terms and a minus sign, but it's like this. 9x to the 3 minus 25x. What's the first thing you notice here? We can factor out an x. So let's factor the x out, and we're left with 9x squared minus 25. Now what we have inside here is a difference of two squares. We need to keep this x. Square root of 9x squared is 3x. Square root of 25 is 5. And we have 1 plus and 1 minus. Okay. Now let's look at this one. 48 x to the 4 minus 3. Okay, neither 48 nor 3 is a perfect square, but we can factor out a 3 here because 3 will go into 48. So we're going to factor out a 3, and we're left with 16x to the 4 minus 1. 16x to the 4 is a perfect square, so is 1. So we have a difference of two squares. So we keep the 3, and we're going to have a 4x squared and a 1. One's going to be plus, one's going to be minus. Now, this one is kind of tricky because notice here that 4x squared minus 1, that's also a difference of two squares. So in order to factor this completely, you also have to factor this one. So what the lesson here is, if you have an x to the 4 or anything that's not an x to the 2, look at after you do the difference of two squares if you have another difference of two squares, because you might. So we're going to keep the 3. We're going to keep the 4x squared plus 1. But now the square root of 4x squared is 2x. Square root of 1 is still 1. And we have 1 plus and 1 minus. So again, if you have an x to the 4 on one of these, after you get down to the first factoring, check to see, look at the negative, the one with the minus sign, and see if it's also a difference of 2 squares, because it may be. Okay, so now let's look at this question. 121 minus m squared. We know that this is a difference of 2 squares. And we could say 11 plus m, 11 minus m. That would be right. There are some times, however, that you need to have the variable first and positive. Some people are just more comfortable with it that way. And then in the next chapter, you're going to have to do that because we're going to do canceling. So what we need to do first is rearrange this to be negative m squared plus 121. All I did was rearrange it. And now, if you remember what I said, we don't want our m squared term or our variable term to be negative. So we're going to factor out a negative 1, and then this becomes negative m squared divided by negative 1 becomes m squared. 121 divided by negative 1 becomes minus 121. And then we're going to have negative 1 times m plus 11, m minus 11. This is the same way as what we did before with just the 11 plus m and 11 minus m. The only reason I'm saying to do this now is because in the next chapter, you're going to have to do it like that. And